Hi everyone, welcome back to my channel. If you are new here, please consider subscribing. In this video, we are going to see how we can convert trigonometric ratios of bigger angles into smaller angles and evaluate them without using tables or calculators. So how to do that? In the previous series of videos, we looked at how we can convert or raise ratios of bigger angles into acute angles, and that's the deal. That's the deal. If you haven't watched those videos, please you can consider revisiting them. But the idea is that first we need to understand the quadrants, and so that stems from having a circle and then subdividing it into four equal parts, and then these are what we refer to as quadrants, with each one being 90 degrees. So the first angle is 0 degrees, and so we have 90, we have 180, 270, and then we have 360. So our angle is less than 360, so that means we need to just stop here, otherwise we can continue making rotations, knowing what is the angle here in the second rotation, and so on and so forth. So in the first quadrant, this is the first quadrant, this is the second quadrant, this is the third, and this is the fourth quadrant. So we always need to understand which ratios are positive or negative and where. So in the first quadrant, all the ratios are positive. In the second quadrant, only sine is positive. Third, only tan is positive. And then in the fourth quadrant, only cos is positive. So when you look at this angle, this is 315. Which angle? We can see that it falls between 270 and 360. So now, we need to ask ourselves, what's that? Where is that angle? So the idea is that we are just going to draw a line within this quadrant, and then know that since 315 is more than 270 and then less than that, then our angle of interest is going to be this angle. So from 0, measuring counterclockwise until we reach this line, and so that's going to be our angle. So that is 315. So that means if along here we have 315, the target is knowing what's this other angle that is remaining. So to know that, we're just going to have our right angled triangle right there. Okay, and so this is the angle. And so to know what's the angle there, we are just going to get 360 take off 315, and so this is going to give us 55. So this is going to give us 45, sorry. So if we take a difference between 360 and 315, this is going to give us 45 degrees. So but what does that mean? It simply means that in this quadrant, cos is a positive, so which means that cos of 315 degrees is the same as cosine of 45. If you can see that straight away, you can always do that straight, but in this case we have to make sure that we show each and every step, so that everyone can get to know where all these steps are derived from. So yeah, so which means that now we can go ahead and evaluate cos of 45. Remember, we are not interested in using tables or calculators, so we need to go ahead and ask ourselves what is cos of 45. And people who are familiar with trigonometry already know the answer here, but again, we need to show everyone where we get that answer from. So from here we can revisit our right angled triangle techniques and see exactly what cos of 45 is. So when you do that, we can see that if this is 90, then this is going to be 45, and this is going to be 45. And in such a case, in such scenario, it's assumed that this is 1 and this is 1, so this side is equal to that. And so the question is always what's the hypotenuse, and which is always equal to 2. So this is in trigonometry, this is a right angled triangle. For the angle 45, we assume that this side is equal to 1 and this side is equal to 1, and so that is root of 2. And so that is from hypotenuse. Hypotenuse squared being equal to 1 squared plus 1 squared, and then h is root of 2, and so that's what we have. So now from here we can generate our angles like sine of 45 being equal to opposite over hypotenuse, opposite over hypotenuse. That is following from this famous shortcut, sohcahtoa. So and then we can generate that sine of this 45 is that which angle is opposite to 45 or the other way around over hypotenuse 1 over root 2, and then the same applies to cos of 45 degrees. This is the same as cosine of 45 adjacent where the angle sits and then over the hypotenuse. So this is kind of like the adjacent over hypotenuse, and then this is giving us 1 over root 2. And so that means technically that this angle here, the whole of that is equal to 1 over root 2, which you can try to rationalize up and down, multiplying up and down, and so that gives us root 2 over 2. And so we can therefore confidently say that cos of 315 is equal to root 2 over 2. And so we have not used any calculators anywhere, but rather some of the basics of trigonometry. So yeah, thank you so much. If you like these videos, please consider